Now to discuss about problems on convergence of the series. The first problem is discuss the convergence of the series 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus up to nth term is 1 by n into n plus 1 plus up to infinity. The solution for this series is here an is equal to 1 by n into n plus 1. So that means nth term. This is equal to, this nth term can be written as 1 by n minus 1 by n plus 1. So here put first we have to put n is equal to 1, 2, 3. So put n is equal to 1, we get a1 is equal to 1 by 1 minus 1 by 1 plus 1, that is 2. Similarly, put n is equal to 2. So we get 1 by 2 minus 1 by 3. So finally put n is equal to n. So we get an is equal to 1 by n minus 1 by n plus 1. Then Sn is equal to, this is what? Sequence. So Sn is equal to a1 plus a2 up to plus an. So Sn is equal to a1. a1 is first term of the sequence, so that is 1 by 1 minus 1 by 2 plus a2 is 1 by 2 minus 1 by 3 up to nth term is 1 by n minus 1 by n plus 1. So here, so in this sequence minus of plus of get cancelled. Similarly minus 1 by 3 plus 1 by 3 cancel. 1 by n is also cancelled. The remaining term is 1 minus 1 by plus 1. So apply limit on both sides as n tends to infinity. So limit of Sn as n tends to infinity is equal to 1 minus 1 by n plus 1. So apply the limit. So we get the value is 1. So here 1 is the finite value. This implies Sn converges to 1. That means the series summation an converges to 1. The second problem, test the convergent of the series summation n is equal to 1 to infinity minus 1 raised to n is equal to minus. So here minus, we have minus 1 plus 1 minus 1 plus 1. So let an is equal to minus 1 raised to n. So here the nth term is minus 1 raised to n, and Sn is equal to, so you put n is equal to 1, 2, 3. So we get minus 1 plus 1 minus 1 up to n terms. Here if n is odd, the value of Sn is minus 1, and the n is even, the value of Sn is 0. So that means here the value of Sn oscillates finitely. Here the value is not unique. So that implies summation n is equal to 1 to infinity an is equal to summation n is equal to 1 to infinity minus 1 raised to n oscillates finitely. And the third problem is test the convergent of the series summation n is equal to 1 to infinity minus 1 raised to n into n. So we get minus 1 plus 2 minus 3 plus 4. Solution. Let an is equal to, here nth term is minus 1 raised to n into n. Next, the sequence Sn is equal to minus 1 plus 2 minus 3 up to n terms. So apply the limit. So limit of Sn as n tends to infinity is equal to, here if n is odd, then the value of minus 1 raised to n into n is minus infinity. If n is even, then the value of minus 1 raised to n into n is that is also minus infinity. So here Sn oscillates infinitely. So get minus infinity. So here if n is even, we get plus infinity. So therefore Sn oscillates infinitely in between minus infinity and plus infinity. So therefore summation n is equal to 1 to infinity an is equal to summation n is equal to 1 to infinity minus 1 raised to n into n oscillates infinitely. And the fourth problem is discuss the convergence of the series. So 1 plus 1 by 3 raised to 1 plus 1 by 3 square plus 1 by 3 cube up to 1 by 3 raised to n minus 1. Solution. Here Sn is 1 plus 1 by 3 raised to 1 plus 1 by 3 square up to 1 by 3 raised to n minus 1. So here this is geometric series. So the first term is 1 and the common ratio is 1 by 3. So here 1 by 3 is less than 1. Therefore formula is Sn is equal to a into 1 minus r raised to n divided by 1 minus r. So Sn is equal to a is 1 minus here r is 1 by 3 raised to n divided by 1 minus 1 by 3. So at denominator 1 minus 1 by 3 is 2 by 3. So when it comes to the numerator, that becomes 3 by 2 into 1 minus 1 by 3 raised to n. So apply the limit on both sides as n tends to infinity. So we get limit of Sn as n tends to infinity is equal to limit of 3 by 2 as n tends to infinity into 1 minus 1 by 3 raised to n. So here when we apply the limit, we get 1 minus here 1 by 3 raised to n is 0. So because limit of x raised to n as n tends to infinity is equal to 0 if x less than 1. So that's why 1 by 3 whole raised to n is 0. So we get 3 by 2. So 3 by 2 is finite value. Therefore the given series is convergent. And the sixth problem is test the convergent of the series summation n is equal to 1 to infinity minus 1 raised to n square is equal to minus 1 plus 1 minus 1 plus 1. Solution. So summation n is equal to 1 to minus 1 raised to n square is equal to, so here first put n is equal to 1, so we get minus 1, put n is equal to 2, so we get plus 4, and n is equal to 3 minus 9, put n is equal to 4, we get plus 16. So Sn is equal to, so minus 1 square, 4 can be written as 2 square, minus 9 can be written as 3 square, plus 16 can be written as 4 square up to n terms. So here apply the limit. So limit of Sn as n tends to infinity is equal to, here we get if n is odd, we get the minus infinity, then we get plus infinity if n is even. So that means the sequence Sn oscillates infinitely between minus infinity and plus infinity. Therefore the series summation an is oscillates infinitely. And the seventh problem is discuss the convergence of the series 1 plus 1 by 2 plus 1 by 4 plus up to minus 1 by 2 raised to n minus 1 plus dot dot. So here Sn is equal to, so 1 plus half plus 1 by 4 up to minus 1 by 2 raised to n minus 1. Here this is in geometric series. The first term is 1 and r is equal to minus half, and Sn is equal to a into 1 minus r raised to n by 1 minus r n 1 minus r. So Sn is equal to 1 minus half raised to n divided by 1 minus of. So at denominator we get 3 by 2. When it comes to numerator, that becomes 2 by 3. So into 1 minus half raised to n. Apply the limit on both sides. So we have limit of Sn as n tends to infinity is equal to limit of 2 by 3 into 1 minus half raised to n as n tends to infinity. So the value of this one 2 by 3. Here minus 1 by 2 raised to n, the value of minus 1 by 2 raised to n is 0 because minus half is less than 1. So its value is 2 by 3. Next, here 2 by 3 is finite value, therefore the series is convergent. So here in this session we have to discuss on problems on convergence of the series. So these are the textbooks to refer for this session. Thank you very much.